Okay, here we go. So we're going to use some trig, some right angle trig. Like I said, we're going to use that right angle trig this week to work on angles in standard position and angles in any position. Those are our two next lessons. So here's the deal, is we're taking right angle triangles and we're placing them on a coordinate plane. Now, as you can see, these pictures are, the triangles are encompassed, inscribed, because it's touching the circumference of the circle. So this is the beginning of your unit circle, but we're baby stepping into it. And I'm hoping that you can hang on to these notes until next year because it's going to be a little bit helpful. So things that you need to know how to do. You need to be able to use your sine, cosine, and tan ratios, which hopefully you did yesterday. You're going to have to be able to deal in degrees, which I think you guys are fine with. You're going to be able to find sides and angles using any of those trig ratios, which I'm assuming you're fine with, and able to use Pythagorean theorem to solve for any unknown side in a right triangle. We just dump in and we expect you to know it, but I hope that you're all pretty comfortable with Pythagorean theorem. And like I said yesterday, just remember that A and B are the legs of the triangle, so that's your base and your height, and C has to be your hypotenuse. Now, people ask all the time, which one's A and which one's B? But because you're adding them, it really doesn't matter. Be consistent. That I find always helps me. Okay, so we've got some new things. We got some new things to learn. Okay, so the initial arm, we're going to talk about initial, terminal, things like that. So the initial arm, I need to grab a pen. Always on the positive x-axis. And so always on the positive x-axis, that's where the initial arm always is. It doesn't move from there. It's where the angle starts, okay? I'm trying to be patient, make sure you've got time to write this down. It's hard, guys, when you're not here. Okay, now the terminal arm is where the angle ends. And the terminal arm can end in any quadrant. So if you're not familiar with kind of the language I'm using, we have our coordinate plane. We know that this is the x-axis, the horizontal is our x-axis. We know the vertical is our y-axis, and everybody's comfortable and knows that sort of stuff. We know that this side is positive, this side is negative, up is positive, down is negative on the y. We're pretty comfortable with that. I'm not sure if you guys are familiar with how we number them. So this is quadrant 1, and for some reason we always use Roman numerals. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. I'm not hung up on whether you use Roman numerals or not, but what you need to know is you start where both of them are positive, and you travel in a counterclockwise direction. We start here because both x and y are positive in a coordinate pair. We're going to get deeper into this tomorrow, and a lot of it you already know, so don't get overwhelmed by it. If the language I'm using doesn't make sense, just stop listening to me for a second, not that you ever need permission to do that, and just start thinking about, like, okay, why would this make sense? How do I remember that this is quadrant 1? And you'll find your way. It's not that big of a deal. Okay, so angles in standard position. This is what the whole lesson is about. So the angles in standard position are angles measured from the positive x-axis. That's it. That's all. That's it. Easy peasy. We just know that our angle starts there, and we are going to, I'm just going to slide up for a second. You guys aren't going to be happy with that. We're going to start here, and we're going to measure to there. We're going to figure out what that angle is. Pretty straightforward. And in this case, it's pretty exciting. It's pretty straightforward. We're going to start there, nice and easy. But then we're going to add to it because, well, you know me, I don't like to keep things at the easy level. We are going to do reference angles. Okay. So this is going to be a positive acute. Now that might not be a word we're familiar with. Acute, which is an angle less than 90 degrees. Measured with the x-axis. Now, you guys are like scanning, and that's the exact same definition that you gave us for the initial arm or the angle in standard position. One word's missing here. This one says positive x-axis. This one just says the x-axis, so it could be on either side. But the thing that you have to remember is that it's tied to the x-axis, not the y. And we'll get a little bit more into this, and there's some common mistakes that people make. And if you notice the notation here, so when we're finding a reference angle, I'm using that theta, and I'm using a subscript r. A subscript has no mathematical implication. It's just kind of like a label. It's saying, hey, this isn't the real angle, but the reference angle is a helper. It helps us find the real angle. Okay, so those are some definitions. Now, if you need to pause here so you can get this all written down, please feel free to do that. Or rewind or whatever. I will have all these notes posted already to the Student Connect. So if you're missing anything, you can always go back and reference it there. Okay, here we go. Calculate the reference angle for the following angles measured in standard position. This is kind of a good activity. This is a super easy lesson, and it's super short. And it's really just getting comfortable with the language. So this is a nice breather of a lesson. Okay, so angle in standard position. So in a standard position, we start from the positive x-axis. So here's my initial arm. I'm going to grab a different color. I'm going to grab pink. Pink never works out, but I'm fingers crossed it's going to work today. And there's pink. So kind of, sort of, okay. So we have our initial arm in orange. So that's where the angle starts. And the terminal arm is where it ends. So what this is saying is that this angle in here, from here to here, is 135 degrees. Well, that's exciting. And now what I'm asking for is that reference angle. So reference angles have to be less than 90, and they are measured off the x-axis. Okay, something you may not know, the angle measure on a straight line, so to go from here to here, is 180 degrees. Any straight line, and you guys know this from using protractors. Sorry, that was squeaky. You guys know this from using protractors in elementary. You guys are proficient in this, but now we're kind of connecting those pieces that you had. So 0 degrees here, I go, sorry, I'm in the way. 0 degrees here, trying to get out of the light. 0 degrees, we go all the way around. 90 degrees, we know that that's a perpendicular. And then if we travel to the straight line, we were measuring on the outside, that's 180. So you know this, but I don't know if we made those connecting points. Okay, so the reference angle in this question is going to be the acute angle made up with the x-axis. We know this isn't acute because that's greater. This one in here is your reference angle. That one in there is your reference angle. So we're trying to solve for that angle. That's what we're trying to solve for, that reference angle. And what we know is a straight line is 180. We know that this part of it is 135. So to find the reference angle, 180 minus our 135. So that's going to give us 45. Hopefully, if I've done my mental math right. And is that an acute angle? Yes, it is. Is it measured against an x-axis? Absolutely it is. Okay, so here we go again. Initial arm. Initial arm is here. Terminal arm is here. And now we're looking for that acute angle, that reference angle. So we know that this whole thing, so we cross that x-axis and we're into the third quadrant, we know that has an angle of 210 degrees. That's the angle measurement from standard position, right? That's that. What we're looking for is the reference angle. And remember that the reference angles are made up with the x-axis. So our reference angle is right here. So it's this little part from here to here. I don't have enough room to draw it in. So that's what we're trying to find this time. So again, we know a little bit about what happened. We know that our reference angle is the whole thing's 210. We know this part is 180. So we're just going to take 210. We're going to minus 180 from it. We should get 30 degrees. And again, I don't put my degree symbols in until the very end. If I have an equal sign here, then I have to have an equal sign here. Okay? I'm making a statement that this is my reference angle. All right. This is kind of where common errors come in. You have to remember that your reference angle is measured from the x-axis. So there's my initial arm. There's my terminal arm. And I know, oh, I grabbed the wrong color. I know that this whole angle is going to be 300 degrees. So that's my standard angle. That's an angle in standard position because I've started here and I've ended at the terminal arm. This is all going to make connective pieces tomorrow that we'll put together. All right. So a lot of people automatically go, my reference angle is right here. That's easy, 270 minus 300, that's 30 degrees. Easy peasy, I'm done. But remember that reference angles are with the x-axis, always with the x-axis. So my reference angle isn't here, it's in here. That's my reference angle in there. So I have to find that one. But we know something about going around a circle, 360 degrees. You're probably pretty comfortable with that. So if we're looking for our reference angle, we know we've traveled 300. And in order to get what's left, we're going to subtract it from 360. You guys are like, Scallion, do I need to show you that math? Because that's pretty straightforward. I know what's left over is 60 degrees. And I would argue that you don't have to show me. You don't have to show me this step. But just make sure in the more complicated ones that you are showing me your math. So this lesson, super quick. Tomorrow's lesson is going to be a little bit longer. But this is the beginning of tomorrow's lesson. So we've got to get good with reference angles. And we're going to make some assumptions about reference angles. Ooh, sorry, dropping my protractor here. Okay, that's it for today. This is a lot of class time to get the next one done. So please use it wisely. You are going to have a quiz on this on Tuesday the 23rd when we get back. So I'll be back at that time. You'll be back. And so my expectation is that you guys are helping each other. You're getting help from your past math teachers, from who's ever filling in for me. So please make sure that you're using all those. I don't want to hear anybody say, well, you weren't here, I couldn't answer it. You are smart people and you have lots of resources. So please make sure you use them. Have a great day, guys. We'll meet again tomorrow.